Okay, welcome everybody. So today we are going to review complex numbers. That is, we are going to basically look at addition, subtraction, multiplication, and division of complex number. So we're going to solve a couple of problems. So question number one, let's see. Suppose we are asked to simplify, simplify 7 minus 2i, 7 minus 2i plus 9i minus 5. So let's see how we can do this. So what is here is we have two complex numbers. So the first one is 7 minus 2i, and we are adding that with 9i minus 5. So this is just the combination of like terms here. You have 7 minus 2i here, and in the other one, if you remove that parenthesis, 9i minus 5. So you can combine the real part with the real part. So that is 7 minus 5, which is a 2. Okay, that's a 2. And then you have 9i minus 2i, that is a 5i. That's a 5i. So your answer is 2 plus 5i. It has a real part and imaginary part. So we are adding two complex numbers here, and our result is also a complex number. So that is the basic addition of complex numbers. Okay, let's check the second problem here. So in the second problem, let's see, let me write a question here. Say, for example, the second question is simplify again, okay? And the question is 5 minus 3i, 5 minus 3i, and then minus or negative 12i. So you are subtracting two complex numbers. This is your complex number, which has both real and imaginary part. The second complex number only has the imaginary part. So when we try to solve this one, same process as the previous one, like in addition. So here we have 5 minus 3i minus a negative 12i. So 5 minus 3i, you are subtracting a negative. So negative and negative, that makes positive 12i. So there is only one real part, 5, but we can combine the imaginary part. So 12i minus 3i, that is a 9i. So that is the subtraction. In the first one, we did the addition. In the second one, we just did the subtraction. Okay, let's try number 3. Number 3, simplify. Let's see, we have 3 minus I multiplied to 6i squared minus 4. Let's find out what is that asking us. So we are asked to multiply these two quantities. So in the first one, we have 3 minus I multiplied with the second one, 6i squared minus 4. 3 minus I multiplied to 6 times I squared is a negative 1. So if we know the value, we can just write it down. I squared is a negative 1, then we have minus 4. So what I'm getting is 3 minus I times 6 times negative 1, that's a negative 6, and then minus 4. So we get 3 minus I multiplied with negative 10. Negative 6 and negative 4 will make a total of negative 10. Now, basically, this 3 minus I is multiplied with 10. So we need to distribute negative 10. So we need to distribute that negative 10. So if I multiply there, or if I distribute, negative 10 times 3, negative 30. And then if I multiply here, negative and negative, that will be positive, and 10 times I is 10i. So we get another complex number, real part imaginary part. When you multiply those two, that's what we get. So you can see that when you're working on the operation involving complex numbers, it is just a regular, algebraic manipulation, addition, subtraction, and multiplication. But the difference is if you see the quantity like I squared or I cubed, you write down the value of that. Always remember that I squared is equal to -1. The imaginary part squared is equal to -1 because I is the square root of -1. Okay, let's continue. Question number 4. Say, for example, in the fourth one, we are asked to divide. So something like this. Simplify 17 over 4 minus I. So in this one, what do we need to do? Let's find it out. So here we have 17 divided by 4 minus I. So you are dividing a real number, which is in fact a complex number also, because there is a 0I. You can think of that way. We are dividing by complex number, 4 minus I. Okay, 17 can be written in complex form. So now, what we can do is, if you are dividing by a complex number, what you need to do is, you need to multiply both numerator and denominator here by the complex conjugate, meaning the complex conjugate of 4 minus I will be 4 plus I. So multiply both numerator and denominator by that. Now see what happened in the numerator? Because when you have two fractions in multiplication, you multiply numerator with numerator. So it will be 17 times 4. Okay, and then we are also doing 17 times I. So first thing is 17 times 4, which is a 68. And then 17 times I, that is a 17I. That's what we get in the numerator. In the denominator, you can see we have 4 minus I multiplied to 4 plus I. So this looks like A minus B times A plus B, which is A squared minus B squared. That is 4 squared minus I squared. So you can write that as 68 plus 17I. 4 squared is 16 minus, and then I squared is a -1. I squared is -1. So what we get is 68 plus 17I divided by 16 minus a -1. So that is same as 16 plus 1, which is 17. Now, when you write the answer for complex number, we write in the form a plus bi. So we separate the real part, which is 68 over 17, then plus 17I over 17. So you can see that this is equal to 68 divided by 17 is 4, and 17 divided by 17 is 1. So 1 times I, that is I. So the result here is 4 plus I. Okay, so main thing here is when you are working on the operation involving division of a complex number, all you need to do is you multiply by the complex conjugate. When you multiply by the complex conjugate and then multiply numerator with numerator, denominator with denominator. And once you get here, you separate the denominator so that you can write your final answer in the form a plus bi. Okay, let's do a few more division problems because division is a little bit tricky compared to other. Okay, so let's see. Question number 5. Question number 5. Let's say simplify 2I over 3 minus I. 2I over 3 minus I. So in this one, unlike the previous one, in the previous one, we have a real number divided by a complex number. Here we have the imaginary number divided by the complex number. But the process is exactly the same. So we begin with what is given here, 2i over 3 minus I. So in order to perform the calculation, you multiply both numerator and denominator by the conjugate of the denominator, complex conjugate of the denominator. We have 3 minus I, so the complex conjugate will be 3 plus I. 3 plus I, just like that. Now, as mentioned before, you multiply numerator with numerator. So if we do that, here we are multiplying 2i with 3. So 2i times 3 is a 6i. 6i. And then 2i times I, that is 2i squared. Divided by, in the denominator, again, 3 minus I times 3 plus I. This is just like a minus b times a plus b, which will be a squared minus b squared. A is 3, 3 squared is 9, minus b squared, that's I squared. So wherever we have I squared, we can replace that by negative 1. So 6i plus 2 times negative 1 over 9 minus negative 1. So that will be 6i minus 2, right? 2 times negative 1. Then over, we have 9 minus a negative 1. 9 minus 1 is a 10. So now we separate the denominator to write in the standard form. So it will be 6i divided by 10 minus 2 over 10. So first we write the real part. So that is a negative. You can see we have a minus. 2 over 10 is a 1/5. Then the imaginary part is 6 over 10, which is same as 3/5 I. So what we get is negative 1/5 plus 3/5 I. And that is your answer for this one, number 5. Okay, one more time. In division, what we have done so far is we divided a real number by complex number. In the second one, we divide an imaginary number by a complex number. Now, in the next one, let's see how we can divide a complex number by a complex number. So we'll do one more example. So let's see question number 6. Suppose the question says, simplify 3 plus 4i over 3 minus 4i. So let's get started. So we have 3 plus 4i divided by 3 minus 4i. So in order to perform this division, we multiply both numerator and denominator by the complex conjugate of the denominator. That means we multiply by 3 plus 4i over 3 plus 4i. Now, in order to multiply this, we multiply numerator with numerator. So it is 3 plus 4i times 3 plus 4i, which is 3 plus 4i quantity squared, over, in the denominator, 3 minus 4i times 3 plus 4i, just like a minus b times a plus b, which is a squared minus b squared. So 3 squared minus 4i squared. Okay? Now, in order to simplify the numerator, which is in the form a plus b quantity squared, we are going to use this formula. A plus b quantity squared is equal to a squared plus 2ab plus b squared. So if you use that formula here, let's see what we get. Okay, a squared, the first quantity squared, 3 squared, 9, plus 2ab, 2 times a is 3, b is 4i, 3ab. Then plus b squared, b is 4i. When you square that, 4 squared is 16, and then I squared. Divided by, in the denominator, we have 3 squared, which is 9. Then minus 4 squared is 16, and then I squared. Okay, now wherever we see I squared, we replace that by negative 1. So it will be 9, then plus 2 times 3 is 6 times 4, 24. 24i, and then plus 16 times negative 1. I squared is negative 1. over in the denominator 9 minus 16 times again I squared is -1. So now let's do it up here. Okay, so in the numerator we have 9 and then minus 16 because 16 times -1 is a -16. So that becomes 9 minus 16, which is a -7. -7. And then plus 24i over. Now look at the denominator. We have -16 multiplied to -1. So that will be positive 16 and 9s. 9 plus 16, that's a 25. At this step, we are going to separate the denominator to write it in the standard form. So -7 has the denominator of 25. So -7 over 25, which cannot be reduced further. Then plus 24 over 25, that cannot be reduced further. 24 over 25, I. So that is my final answer. Okay, so we got the final answer, which is also a complex number. So always remember when you're dividing a complex number or you're dividing by a complex number, I would say, you multiply both numerator and denominator by the conjugate of the denominator. Then multiply the numerator with numerator, multiply the denominator with denominator. If you see I squared, replace it by -1. And then at the end, you separate the denominator to write it in the standard form. So that is how we can perform the basic operations of complex numbers. So for this video, we are going to end here. Thank you for watching.